The stunts we love to watch in movies like Spider-Man: Homecoming usually rely on a mix of stunt performers, green screen, and computer-generated models. Stunts like these, where Spider-Man flies through the air, can be dangerous, especially if they're being performed live, over and over and over again. But at the new Adventures campus at Disneyland Resorts, these stunts are being done every day by this guy, a robotic acrobat. It's part of a Stuntronics technology system developed by a team of roboticists and engineers. Wired spoke with Imagineers Tony Dohey and Morgan Pope to discover what it took to design, launch, and catch the Stuntronic acrobat. While this flying Spider-Man may look human, it's actually a complex robotic system covered by a 3D printed shell.
Ultimately, the two driving design things for the Stuntronic robot were this idea of robustness and grace. It also had to communicate the fluidity of a human performance. It had to be believable and alive.
Yeah, it had to look like Spider-Man.
So Tony and I were working on kind of parallel paths. You know, he had this idea for throwing a robot across the room. And meanwhile, over on the research side, I was working on how do you control something as it's free falling through space.
To tackle the challenge of creating a totally controllable robotic system that mimics the uncontrollability of flight, they started their design with this, the brick.
The idea here was that we could spin it through the air and it had these weights inside that could move.
It didn't look like a character, but it had all the intelligence in it. It had sensors, it knew how high it was from the ground.
Their next prototype didn't look much like a character either.
So this right over here is our prototype.
This actually has that bend that's a lot more, this is how a human shifts inertia, right? Kind of it would tuck and do a flip and lay out.
And so from that we moved really quickly. Like maybe the next day we started building Stickman. It's actually a Z-shaped series of linkages.
It's like the engineering version of Lincoln Logs or Legos. And you get this kind of double pendulum, which is like a classically chaotic system, which means it's kind of a bear to control, but it also means you can do really fun stuff. If you squint at it, it starts to look like a human. This is the first time we could get asymmetric motion, right? This guy can move this arm and not this arm and do all sorts of like twists and stuff.
Then they moved to half-scale figures. And finally, their series of full-size Stuntronic robots.
They weigh about 95 pounds, and their height, I would say, is 5'9".
We constructed them out of mainly 3D printed plastic and aluminum, and a lot of screws. Yeah, right, a lot of screws.
So we started with a 40-foot high throw,
right.
Maybe not even that.
Yeah, it was like 40, 45, which was twice what we were doing inside.
So we started to tune up the power on the winch, and we kept throwing this higher and higher and higher till we pretty much peaked out the winch.
Yeah, around 65 feet.
Yeah, throws are about 65 feet high in the air.
And there was this kind of magical moment where I think it's around 55 feet. It feels like shouldn't it have come down by now? Like, you know, like it feels like it's floating. That was a cool moment. Then internally, the robot keeps track of its position using the same basic sensors that are in your phone. It uses an accelerometer and a gyroscope. So the same thing that tells you if it's portrait or landscape.
The only external sensor I can say we have is one that's really more tied into the show control system, and it's the anemometers. Yeah. Because we really need to be very, very aware of the wind speeds.
We took measurements of the weather at Disneyland for like a year so that we can be really conservative about how the robot flies through the air and make sure that we always hit the net.
Creating the illusion of Peter Parker as Spider-Man flying through the air was an ongoing design and engineering challenge.
Robots are designed to be precise, and they're not designed to make mistakes and be clumsy or show panic.
Right.
So the question is now, how can we capture Spider-Man out of control flying through the air?
Oh, that was a really fun challenge.
That just took so many iterations to
get
that dialed in.
When we were indoors, we had a whole motion capture system set up so that we could validate that our sensors were actually giving us precision to within a few centimeters, which is the kind of precision we needed to do what we wanted to do. So I think as human beings, we understand like things spinning in one plane pretty well, but when you start flipping in 3D space, things get weird physics-wise. For instance, if I'm doing a front flip like this and I have my arms up, if I throw my arm down like this, I'm going to tip a little bit, but then I'm also, out of nowhere, I'm going to start like twisting around this axis. Now you've gone from just a straight front flip to a twisted, slightly tilted, tumbling, and the physics you can write on one line. It's a very simple equation, but then what pops out of it is so counterintuitive and honestly so beautiful. And I think that's kind of the fun part about how, moving from the brick where it was very much in 2 dimensions to the more complicated, where you've got cross products of inertia, you've got this more complicated human-shaped object that can do all these weird things in 3D dynamics. And that suddenly made it feel really alive.
The catchment system is very, very specific. So not only do we have to be able to catch the figure, decelerate it very quickly, but that net also has to be robust enough to do this over and over and over again, because we don't want to replace it every show. The net area is only about 10 feet by 10 feet.
I think 14, which sounds big, but then when you get on the roof and if you look from the position of the robot 65 feet in the air, it doesn't feel very big. It's another good reason we don't do this with people.
And it has a deceleration system it's just beautifully simplistic in its design.
Yep.
But it's also very quickly resettable. The robot was designed to actually have some breakaway linkages.
Right.
So that if we land in a funny way, for instance, we're only going to break a 3D printed part that's designed to snap so that we don't transfer that impact to the more delicate or more expensive parts like the servos.
That actually has been a cool thing. We've done some pretty violent things to our robots in the course of testing. You design it so that if it breaks, it's not a big deal. It goes all the way back to Stickman.
We're always thinking of what the next thing might be.
I think ultimately we designed this system with the hopes of it being flexible and adaptable, and there are so many dynamic characters in the Disney pantheon, and we hope that we can deliver more of them for real.
Centronics isn't a robot, it's a category of stunt robots. So